Bismillahirrahmanirrahim. Assalamu alaikum students. This is Hamza Noor from Aero Education Network, and today I'm going to solve some past paper questions from A-level Maths Mechanics Cambridge 9709, and the topic is kinematics, and specifically I'll be addressing the velocity time graph questions, and in particular when the velocity time graph comes under the horizontal axis. So we have some past paper questions. So let's start with the first question. This is question number 12 of the handout, which is May-June 2010, paper 4, variant 2, question number 2. So the question says that it shows the velocity time graph for the motion of a machine's cutting tool. The graph consists of 5 straight line segments. The tool moves forward for 8 seconds while cutting and then takes 3 seconds to its starting position. Okay, so in the first 8 seconds, the tool is moving forwards, okay, because the velocity time graph is above the horizontal axis. And then in the last 3 seconds, the tool is coming to its return journey, meaning the tool has changed the direction of its motion. Okay, so basically from t is equals to 8 to t is equals to 11, we have the backward journey of the tool. Okay, so above the horizontal axis, graph is basically the forward journey, and below the horizontal axis is the backwards journey. So in part 1, it's required to find the acceleration of the tool during the first 2 seconds of its motion. Okay, so what we need the gradient of this upward sloping line, because in the first 2 seconds, we need to find the acceleration. Okay, so for part 1, what we are going to say that we are going to find the gradient of the upward sloping line, meaning we consider the journey from t is equals to 0 to t is equals to 2 only. So acceleration is equals to v minus u over t. Okay, you can use this formula. So acceleration is equals to 0.18 minus 0, since the initial velocity is 0 and the time taken is 2 seconds. So 0.18 divided by 2, this is 0.09 meter per second square. As simple as that. This was the requirement of part 1. All right. So now in part 2, it is required to find the distance the tool moves forward while cutting. So what we need to find, we need to find the area above the horizontal axis. We need to find the area of this complete trapezium, because when the tool is moving forwards, so the velocity is positive. So the graph is above the horizontal axis from t is equal to 0 to t is equals to 8. All right. So in order to find the distance when the tool is moving forwards, we need to find the area above the horizontal axis, meaning in part 2, we need to find the area of trapezium. Okay. So this will basically tell us the displacement. And in this case, since when the tool is moving forwards, it is not changing the direction of motion, so the displacement and distance will be the same. So area of trapezium is going to essentially give us the distance traveled by the tool while moving forwards. Okay, so area of trapezium above the horizontal axis. Okay, so you don't need to mention this complete English in the question. You just need to apply the concept. Here I'm just mentioning this thing for your ease as a part of the working. This will tell us the distance which tool moves forward. Distance covered by the tool while moving forwards. Okay, so we need to find the area of this trapezium. So what we can see is that height of the trapezium is 0.18, because height is basically the perpendicular distance between the two parallel sides, and one parallel side is 8 and the other parallel side is 6 minus 2, meaning the other parallel side is 4. Okay, so these are the two parallel sides, and height is basically the perpendicular distance between the two parallel sides. So half into height into sum of parallel sides. meaning half multiplied by 0.18 multiplied by 4 plus 8. Okay, so 0.18 into half is 0.09 and 4 plus 8 is 12. So 0.09 times 12, 1.08 meter will be our answer. Okay, so far we have attempted part 1 and part 2. All right, so now having a look at part 3. The requirement for part 3 is to find the greatest speed of the tool during the return to its starting position. So here we need to find the greatest speed. Okay, so this essentially means that we need to find the height of the triangle which is below the horizontal axis, because this will basically tell us the velocity over here, and here the velocity is going to be negative because the tool is coming backwards. Okay, it is on the return journey, and what we know the fact is that the area of the trapezium which is above the horizontal axis, which was 1.08, will be exactly equal to the area of this triangle which is below the horizontal axis. Okay, because if you consider this journey from t is equal to 0 to t is equals to 8. Okay, what's happening is that the displacement is 1.08 meter, which tells us that the distance is 1.08. But after t is equals to 8, tool has changed the direction of its motion. So from t is equals to 8 to t is equals to 11, the displacement will be minus 1.08 meter. This t is equals to 8 to t is equals to 11 is basically the return journey of the tool, and this tells us that the tool has covered a distance of 1.08 meter as well while moving backwards, which tells us that the displacement is minus 1.08 meter. Okay, so at t is equals to 11, our displacement will be 0, which is 1.08 minus 1.08. At t is equals to 11, the tool has returned to its starting position. Okay, so this is basically what's going on over here. Okay, so for part 3, what we are going to do, I'm just going to bring the picture of the sketch over here. The picture of the sketch over here only. Okay, we need to find the greatest speed, which I've already mentioned that, which is the height of the triangle which is below the horizontal axis. I'll bring the picture over here. Okay, this position is perfect. So what I'm trying to tell you is that the area of the triangle which is below the horizontal axis, this is also 1.08. Okay, so we are going to say that area of triangle, area of triangle which is below the horizontal axis, which is below the horizontal axis, is also 1.08. Okay, if you just consider the area from t is equals to 8 to t is equals to 11, the displacement is minus 1.08 because the velocity time graph is under the horizontal axis. But if you just consider the area, so obviously area would be 1.08, but this would essentially mean that the displacement is minus 1.08 meter. So what I'm trying to tell you is that the base of the triangle we know is 3, because 11 minus 8, the base of the triangle is 3, and height we don't know. Okay, and we need to find the height of this triangle over here. Okay, so that's basically the thing. So what I'm going to say is that I'm going to say that half into base into height, meaning the base of the triangle is 11 minus 8, which is 3, and height is basically unknown, and this will be equal to 1.08. Okay, so 3 over 2 into height is equals to 1.08. Therefore, the height of the triangle is supposed to be 1.08 multiplied by 2 divided by 3. Okay, so height is 0.72. height of the triangle is 0.72. Therefore, the greatest speed achieved by the tool in the backward journey is basically 0.72. If the velocity was asked, if the question says that find the velocity, so velocity would be minus 0.72. Obviously, because this velocity would have a negative value. Okay, so this would be minus 0.72 if the velocity was asked. But we need to tell the speed, so therefore we are going to say that the greatest speed is 0.72 meter per second. Greatest speed is 0.72 meter per second, and in this way we have attempted this part 3. All right, so this was basically the complete question, which is handout question number 12, which is May June 2010, paper 4 variant 2, question number 2. So now let's move on to the next question. So the next question is handout question number 15. This is October November 2010, paper 4 variant 2, question number 6. All right, so the question says that the diagram shows the velocity time graph for a particle P which travels on a straight line AB, where v meter per second is the velocity of the particle at time t seconds. The graph consists of 5 straight line segments. The particle starts from rest when t is equal to 0 at a point x, okay, on the line between A and B, and it moves towards A. The particle comes to rest at A when t is equal to 2.5. And in part 1 it says that given that the distance xa is 4 meter, find the greatest speed reached by the particle during this stage of the motion. So if we just consider this part 1 and focus on part 1 only. So first of all, what's happening is that the starting point is point x. Okay, on the graph it is mentioned that it is origin. However, actually it is point x. So at point x our journey is started. So at point x we can say that time is equal to 0. But what's happening is that first the graph is coming under the horizontal axis. Initially, the particle is moving backwards. So if I make a sketch on a horizontal line over here, so if I consider the right hand side direction to be positive, so basically what's happening is that the particle is moving towards left initially, okay, and it is coming at point A. Okay, when we consider the right hand side direction as positive, so particle is initially coming towards A, and after this the particle will change the path of its motion. So we are going to talk about that in the next part. Right now we are just focused on part 1. Okay, the right hand side direction is positive and particle is coming towards A, and then after which it will change the direction of its motion. Okay, so what we know, the fact is that over here the information which is given to us in the question, that the distance xa is 4 meter. This distance between point x and point A is 4 meter. But if we talk about the displacement, so displacement would be minus 4 meter, because the particle is initially traveling backwards. Okay, and then after point A it will start to move forwards. Okay, so when we consider the journey from x to A, we are going to say that the displacement is minus 4 meter. All right. Now, usually what happens is that wherever the particle goes initially, we consider that particular direction is positive. That is basically the usual practice. But according to the scenario of this question, what we are going to say that since initially when t is equal to 0, meaning the first stage of the journey from, if you consider this is stage 1 of the journey, which is below the horizontal axis, from t is equal to 0 to t is equal to 2.5, since the velocity time graph is coming under the horizontal axis, so initially the particle is moving backwards. Okay, so these are the basic concepts behind this. I hope everything you have covered before attempting the past paper questions. All right. So what we are going to say that in part 1, the area of this triangle is 4. The displacement is -4, but when you consider the area of this triangle, which is below the horizontal axis, it will have an area of 4. I'm going to say that area of triangle is equals to 4. All right. And the base of the triangle is basically 2.5. Okay. And height, we don't know, because we need to find the height over here, because the requirement is to find the greatest speed reached by the particle during this stage of the motion. Okay. If the velocity was asked, obviously velocity would have a negative value, but the greatest speed is asked. So first we are going to find the height of the triangle. So I'm going to say that half multiplied by 2.5 multiplied by height is equals to 4. So height is equals to 4 multiplied by 2 divided by 2.5. What is the value? 8 divided by 2.5. This is 3.2. The height of the triangle, which is below the horizontal axis, this is 3.2. Therefore, we are going to say that the greatest speed is 3.2 meter per second. Greatest speed in part 1 is 3.2 meter per second. In this way, we have attempted this part 1. All right. So this was the complete working for this part 1, which was worth 2 marks with some extra explanation, okay, which needs to be explained over here before attempting the question. So now let's move on to part 2, 3 and 4, and here we have some story to understand. Let's see what's happening. It says that in the second stage, particle P starts from rest at A when T is equals to 2.5. Okay, it starts at rest, meaning the velocity at this point is 0. Okay, because initially when particle started from X, it moved towards A, and after this, the particle will change the path of its motion. Okay, so after T is equals to 2.5, the velocity is going to become positive. So it says that in the second stage, particle P starts from rest at A when T is equal to 2.5 and moves towards B. The distance AB is 48 meter. The particle takes 12 seconds to travel from A to B and comes to rest at point B. For the first 2 seconds of this stage, T accelerates, meaning from T is equal to 2.5 to T is equal to 4.5, we are accelerating. Okay. And we are accelerating at a rate of 3 meter per second square, which means that the gradient of this upward sloping line is basically 3, and reaching a velocity of v meter per second. Okay, so part 2, first of all, we need to find the value of v. Okay, so what I'm going to do is I'm going to bring the sketch over here as well, the sketch of the graph which is given to us in the question. All right, I'm going to crop this picture, and first of all, I'm going to make a horizontal sketch which I made over here to make you understand how the particle is, moving. What we know, the fact is that the particle started its journey at point X when t was equal to 0. At point X, we are going to say that t is equal to 0, and at point A, the time is 2.5 seconds, and the distance between X and A was 4 meter, which we have already seen in part 1. So when the particle started its journey, so basically the right hand side direction is positive, and initially the particle started to move backwards. And from X till A, the displacement is -4 meter, because the velocity time graph was under the horizontal axis. Okay, so far you have seen this thing in part 1. Now what's going to happen is that I'm going to use a blue pen over here. Okay, so after reaching point A, particle has changed the direction of its motion, meaning from t is equal to 2.5 and onwards, particle has started to move forwards. Initially, the right hand side direction was positive and particle was moving backwards. And now basically what's going to happen is that particle will move forward. So I'm going to use a blue marker over here and I'm going to make a horizontal line. Okay, to make a good looking sketch. All right. So basically, when the particle started to move forwards after t is equals to 2.5, so we are basically given the gradient of this upward sloping line, which is 3. Okay, as per the information of the question. For the first 2 seconds of this second stage of the particle accelerates at 3 meter per second square. What I'm trying to tell you is that if I explain you the whole story, the particle takes 12 seconds to travel from A to B and comes to rest at B. Okay, so here basically you have point A when t was equal to 2.5 and particle comes to rest again at point B. Okay, and particle has covered a total distance of 48 meter over here from the journey from A to B. Okay, particle has covered a complete distance of 48 meter from A to B, meaning from t is equals to 2.5 till t is equals to 14.5. So this essentially means that the area of this trapezium, which is above the horizontal axis, this is 48 because particle has moved a distance of 48 meter from point A to point B. This makes sense to you or not? So this is basically the whole story, whole explanation. Okay, now let's come to the point. Part 2. In part 2, we have the requirement to find the value of V. All right. So we know that the gradient of this upward sloping line is basically 3, meaning the acceleration is 3 over here. Okay. So for part 2, I'm going to say that acceleration is equals to V minus U over T. And since the acceleration is 3, final velocity is unknown, which is V. We need to find the value of V, and U is basically 0 because at t is equals to 2.5, particle is at rest, and the time duration is basically 4.5 minus 2.5, meaning we are talking about 2 seconds over here. Okay, so V is equals to 3 multiplied by 2, which is supposed to be 6. So V is equals to 6 meter per second. This is the answer of part 2. This makes sense? All right. Now let's come on to part 3 and part 4. The whole story I've already explained, okay? This story I've already explained. Now this question is a piece of cake for you. Part 3 is saying that the value of t at which the particle p starts to decelerate during this stage. What stage? The second stage, when the particle is moving forwards. Okay. So the value of t at which particle p starts to decelerate. The deceleration is starting over here, as you can see. So this value of t is basically unknown. We need to find this value of t over here. Okay, so let's mark this value. Let's mark this value of time as t, where t is unknown. And what we know the fact is that the particle has covered a distance of 48 meter when moving from point A to point B. Okay, so the area of this trapezium, which is above the horizontal axis, is 48. Okay, this area is basically 48 over here. All right. So I am going to say that I'm going to find the expression for the area of trapezium, and this will be kept equals to 48. So what we can see is that the height of the trapezium is V, and V we have already found in part 2, which is 6. So height of the trapezium is 6, and one parallel side is 14.5 minus 2.5, meaning 12. Okay, one parallel side is 12, and the other parallel side is basically t minus 4.5. T minus 4.5. This parallel side is supposed to be, first you have t, and then you are subtracting 4.5 over here. So this parallel side is t minus 4.5. All right. And what you need to do, You just need to solve this equation and find the value of t. All right, so 48 multiplied by 2 divided by 6. This is equals to what? 12 minus 4.5 is 7.5. So this is equals to 7.5 plus t. So 48 multiplied by 2 divided by 6. This is 16. So 16 is equals to 7.5 plus t. So therefore, t is equals to 16 minus 7.5, meaning t is equals to 8.5 seconds. So t is equals to 8.5 is basically the answer to part 3. So now let's see part 4, the last part of this question. All right. So in part 4, the requirement is to find the deceleration of particle immediately before it reaches B. Okay, because when the particle reaches B, as we have seen above, it is when t is equals to 14.5. Okay, so the journey has started from X, then at t is equals to 2.5, we were at point A, and then at t is equals to 14.5, we were at point B. All right, so we just need to find the gradient of this downward sloping line, which is supposed to be a negative value, and the answer will be deceleration, which is a positive value. So for part 4, what I can do is I can use the formula for finding the value of acceleration. Acceleration is equals to v minus u upon t. Okay, and here the time is 8.5 seconds. Okay, when the journey starts to, when the particle starts to decelerate. So when the particle comes to rest at point B, when t is 14.5, so the velocity is 0. Okay, the initial velocity is the value of v over here, which we found in part 2, which was 6 meter per second. Initial velocity is 6 meter per second, and the time duration in this very last stage is 14.5 minus 8.5. Okay, so minus 6 divided by 6. So acceleration is equals to minus 6 divided by 6, meaning acceleration is minus 1 meter per second square, but we want to find the value of deceleration. Therefore, deceleration is 1 meter per second square. This is supposed to be our answer to part 4. All right, so this was basically question number 15, which is October-November 2010, paper 42, question number 6. Okay, and as far as some other requirements would have been concerned, if I give some requirements from my own side. So let's bring the sketch of this page over here. The screenshot of the sketch which I made, the horizontal line is sketch. Okay, so I'll bring it over here. Let's say if I ask you what is the total distance, okay, what is the total distance traveled by the particle from point X to point A and then to point B, meaning the total distance traveled by the particle in the complete 14.5 seconds. So you are going to say that from X till A, we were having a displacement of minus 4 meter, meaning a distance of 4 meter on the opposite side. And then from A to B, the distance of 48 meter, okay, on the forward side. So if I ask you what is the total distance traveled by the particle in 14.5 seconds, so this will be 4 plus 48, which is 52 meter. Okay, this makes sense. These things can be asked as well. All right. If I ask you, if I give a part 5 on my own, find the traveled, total distance traveled by the particle, total distance traveled by P in 14.5 seconds. Okay. If I give you a requirement on my own, so 4 plus 48, meaning 4 meter distance you have covered on the backwards journey, and 48 meter you have covered in the forward journey. So answer would be 52 meter. So for the purpose of this video, I've discussed two questions, and this was October-November 2010, paper 42, question number 6. So inshallah, I'll be uploading more videos soon. So stay tuned to my channel. Thanks for watching. Assalamu alaikum.